We already solved up to a question of number of 14, right? So let's discuss today's question, that we start from the question number 15. So what exactly given in this particular problem? It is given there is a pipe which is closed at a one end. So right now let me draw a pipe which is closed at a one end. Right, we have a one pipe which is closed at one end. This is a closed end and this is a open end, right? It can produce overtone. There are different frequencies are mentioned over here. Frequency is a 640 hertz which is given, then it is 896 hertz given, then 1152 hertz which is given, right? So these are what these are overtone. This is not a, we can say that it is not a it is not a fundamental harmonic, it is not a first overtone, it is not a second overtone, it is not like that. Okay, so we need to calculate the fundamental frequency. They ask you to find out what is the value of n, and we know that in a pipe the fundamental frequency is equals to v upon 4l, v upon 4l, something like it is given over there. But exactly in this particular problem we don't know the value of a n, but these are the overtones, but we don't know the what overtone it is. So this is say any overtone. So in order to identify or in order to represent a frequency of any overtone, so frequency of p overtone will be is equals to, in a pipe we are supposed to get a frequency of a in a pipe close at one end, the frequency is of a odd multiple, so odd multiple of a n, so twice p plus 1 into n. So this is a, say this is a pth overtone, this is say pth overtone, right? As it is a pth overtone, right? It is a say pth overtone, and the value 640 hertz it is mentioned over here, that is nothing but a frequency of pth overtone. It is denoted by the letter np, and which is a odd multiple of n. So how to find out its frequency? What is the value of p over here? So is it a first overtone, is it a second overtone, is it a third overtone? That we don't know. So I just mentioned 640 as nothing but a np, as nothing but a, so np is equals to 640. So this is the frequency which comes higher than a this. So this is 890. So I'm going to mention this is what np plus 1. So this is the frequency which is nothing but a come after larger than the 640. So that I'm just going to consider it is a frequency higher than that. So if it is a pth overtone, this is a p plus 1 overtone. So that's the reason why I'm going to mention that frequency, that is n p plus 1 will be is equal to, instead of p right now, here I'll mention that is equals to p plus 1 into n. This also you can mention like this is the frequency of a p plus 2, because after p plus 0, that means np, then afterward this is p plus 1, np plus 1, the frequency of the p plus 1 overtone, right? This is the frequency of a p plus 2 overtone, right? So if I take a p is equal to say 1, it will be n1, this will be 1 plus 1, that will be n2, this will be 1 plus 2, that is equal to n3, something like that. But we don't know the value of p over here, what exactly it is. So we can mention here formula, that is n p plus 2 will be is equals to 2 into, now instead of here p, what I am going to write down, that is p plus 2 into plus 1 into n, right? So you can simplify, either take this equation or this equation, or you can take any pair. You can take this first one, this you can take the second one, you can take this third one, right? So you can take any number, right? So I'm going to take this np, np it is already over there, so this np plus 1 will be is equals to twice of, just multiply p inside, twice p plus 2 into n. But np plus 1 is equals to what? Np plus 1 is equals to 896. So 896 hertz will be is equals to twice p plus 2 into n. Let's say this is equation number 2, and right now already we have np is equals to what? Np is equal to 640. So 640, okay, I'll write now 640 will be is equals to twice p plus 1 into n. Now this is equation number say 1. Now let's simplify this equation. So what to do? then you can divide this function. Just what to do, just divide this equation 2 by equation 1, right? Divide equation 2 by equation 1, right? So what exactly you will get by dividing equation 2 by equation 1? So the situation here you will get, for example, let me just take a page little up. Okay, so I'm writing equation which one? Equation 2. Write down equation 2, that is twice p plus 2 into n. The right hand side of that equation is divided by this part, that is twice p plus 2, right? Right, twice p plus 1 into, okay, something is missing over here. What is missing? So instead of in this part, instead of one plus missing, means you have one plus missing. That means it should be, instead of 2, here should be 3. Okay, now finish. Into n will be is equals, now twice p plus 2 into n. Okay, something is wrong over here. So what is wrong? Okay, just hold on a second. Let's take a example number. Say which example I'm talking about. I'm talking about this equation number 2. So what is wrong over there? This, instead of p, we mention over there, that is equals to p plus 1. So 2 into p, that is twice p. 2 into 1, that is 2, and this remaining 1 will be remain over there. So here what it will become? It will become 3. So 2 into 1, 2, 2 plus 1, 3, right? So twice p plus 3 into n, it will be there. So write down equation number 2. So that is twice p plus 3 into n, okay, whole divided by what factor? This factor, that is twice p plus 1. Twice p plus 1 into n will be is equals to, now what is twice p plus 3 equal to? That is equals to 896 whole divided by, what is that? 640. That is equals to 640. Now what to do? Simplify this. Now let's simplify. This n and this n will get cancelled. Twice p plus 3 will be equals to, okay, I'll write, I'm over here. Okay, twice p plus 3 whole divided by twice p plus 1 will be is equals to 896. Either you can simplify this or you can keep as it is. Well, it is better to simplify, right? Okay, by what number you can divide? Let's take a 2. 2 3s are, 2 2s are, and 2 0 0. 2 4s are, again 2 4s are, and then 1 remain, that is 2 8s are, right? So still we can simplify this. That is equals to, again 2 1s are 2, then 1 will remainder, that is 2 6 are 0, then again 2 2s are, 2 2s are, 2 4s are, right? Okay, so still 4 4s are 40, 4 are 160, 40 5s are, and what will remain? That is equals to 4 5s are 20, and 4 will remain over there. So 4 6 are, so 56 divided by 40. So it is quite easy to now solve this problem. Now twice p plus 3 into, okay, divided by twice p plus 1 will be is equals to 56 by 40. Cross multiply this. So either again you can divide this, again you can simplify this 56 by 40. This you can simplify again by which number? Again say again you can take the division over here. So what division over there? That is nothing but a save. Take a 2 2 2s are 2 10s are, right? 2 2s are 4, then 1 will remain, 2 8s are, right? 4 5s are 4 7s are 7 by 5. Okay, very easy. Now which is equals to 7 by 5. Now cross multiply 2p plus 3 into 5, that is equals to 10p plus 15 will be is equals to 2p plus 1 into 7, that is equals to 14p plus 7, right? Take a plus 7 to this side, take a 10p to that side, right? So what the simplified form there you will get, that is nothing but a say here this 15 I'm keeping as it is, right? I'm taking this plus 7 to this side, it will become minus 7 will be is equals to this 14p will be remain as it is, then 10p plus 10p it will become minus 10p, right? So 15 minus 7, that is equals to 8 will remain over there, is equals to 4p. So p will be is equals to 8 by 4, so that is nothing but a 2. So we got the value of p is equals to 2, right? So as we got the p, still our problem is not yet solved. So okay, so how to solve this particular problem? So again we need to reach to this particular part. Which part? This part, right? So p is equals to 2, so that means we got n2 will be is equals to, instead of p we will place the 2 because p equal to 2 we got, n2 is equals to 640, right? But n2 is equals to 640, then twice p plus 1 is equals to, okay, again p is equals to this 640 is equals to what we'll get, 2 into p, so 2 into p plus 1 into n, that will be also 640 because this factor I'm just equating, right? So what is 2? This p is nothing but a 2, so 2 into 2 plus 1, right, into n will be is equals to 640, right? So 2 to the 4, 4 plus 1 5, so n will be is equals to 640 divided by 5, and this is nothing but a your answer, that is 128. So this factor you will get, that is equals to 128, right? So this is the solution of this particular question number 15. Now let's move towards question number 16, right? So question number 16, here we have a standing wave is produced in a tube open at both ends. Again we have a pipe which is open at both ends. I'm drawing a pipe over here, right, which is at a open at both end. Right now the fundamental frequency here, it is equals to 300 hertz. So n is equals to, we got, that is equals to 300 hertz, it is there. Right now what's supposed to happen? A stationary wave is there. In a fundamental mode we knew that a wave supposed to be, say this is a wave. Okay, just hold on a second. Okay, just hold on. So something like that will have a, this is a wave which is going to say, which is incident wave, and say this is a, say, reflected wave, right? So this is a reflected wave, and here will formation of antinode, here will form antinode, and this is nothing but a length of that particular pipe, and which is equals to nothing but a distance between this two antinode, right? Here at this point antinode will form, at this form antinode will form. Okay, chalo, let's move forward for the problem. Right now what is the length of the tube? Here it is a velocity or the speed of sound is given, that is v is equals to 340 meter per second. Here minus 1 it is there, meter per second minus 1, right? Meter divided by second, also you can write it down. So they ask you to find out what is the length of this, L will be equals, but in this problem L will be is equals to, what is this? L is equals to distance between two antinode. L will be is equals to distance between two antinode, distance between two antinode. So what is the exact distance between two antinode? That is equals to distance between two antinode, that is equals to lambda by 2. So lambda is equals to, you will get twice L, right? This 2 will get multiplied to the L. Right now for the we have formula, that is v is equals to n lambda, right? V is equals to 340 meter per second, it will be as it is. N will be is equals to, say, 300, and multiplied by the value of lambda is equals to twice L, that is equals to twice L, right? We wanted to find out L, so So 340 will be remain as it is. 300 into 2, that is equals to 600 L. Take a L will be is equals to this side. So that is equals 340. Oh, sorry, 340 divided by 600. Yes, 600 it is. 0 0 will get cancelled. Now if you divide 34 by 60, this value will get, that is equals to 0.57 meters. So this is nothing but a answer of your question, right? This is very simple. You can divide, or otherwise I'll in a simplified manner I'll divide for you. What it is, 34 divided by 60. Right now 60 is a larger number, we can't divide, so take a 0, take a 0 point. Now what to do? 6 are 36, but 6 5s are 30, so 65 is a 300. 65 is a 300. What will remain? 40 will remain. Again 0. 66 are 360. What again will remain? 60 will remain. Then again 0 I am going to take. So 66 are. So again 0.566. So recurring 666 again it will come. So I just want this letter, this particular digit, and I'm going to drop this whole thing. So whatever the digit I want to drop, which is greater than 6, so it will become so it will get greater than 6. So we need to add in that letter, so it will become a 0.57. So the problem is over. Now let's move towards problem number, say, 17. Now in a problem number 17, what exactly it is there? Find the fundamental first overtone. So we wanted to find the fundamental frequency, the frequency of the first overtone and the second overtone of a pipe open at both ends. If the length of a pipe is given L equal to 25 centimeter, L is equals to 25 centimeter, that means 1/4 of meter, right? 1/4 of meter. We have L we got, that is equals to 25 centimeter, that is equals to 1/4 meter, right? 1/4 of meter. And the speed is given, that is equals to V will be is equals to 330 meter per second. Now they ask you to find out the frequency in which pipe. Now that pipe I'm going to draw over here, that pipe which is open at both end. And in a pipe, frequency in a first mode, in a fundamental frequency, that is equals to n, that will be is equals to V upon twice L. V upon twice L is nothing but a frequency of a fundamental frequency, first overtone of the, we can say that, sorry, zero overtone or a first harmonic, right? Frequency in a first overtone, that is equals to twice V upon twice L. Frequency in a, say, in a second overtone, that is equals to N2, that is equals to, we can say that, thrice V upon twice L, right? So first of all, just try to find out this factor. So V is equals to 330, right, divided by 2 into L is equals to what? L is equals to, L we have 1/4 meter into 1/4 meter. So 2 1s are 2 2s are, right? This 2 will go to the numerator. So N will be is equals to 330 into 2, right? So that is equals to 660 hertz. So this is nothing but a frequency of a fundamental frequency, or the frequency of the first harmonic, and that is the answer. Right now you can simplify, you can place the value of n over here. So this is equals to n, this is equals to n, right? So n1 will be is equals to twice n, and n1 will be is equals to 2 into n is equals to what? 660 hertz. It is equals to 660 hertz. So 662 is a 1320. So n1 will be is equals to 1320 hertz. So this is the frequency of a first overtone. So that is the answer. Now next, n2 will be is equals to thrice of n, because V into twice L, this factor is equals to n, right? So 3 into 660, right? 3 into 660, that is equals to 1980 hertz. So this is nothing but a solution of this whole problem. Okay, so we got the frequency of first overtone, we got the frequency of a second overtone, right? Okay, so this is the situation here. So we got a 660 hertz, so we got a 1320 hertz, so we got a 1980 hertz. So these are the solution of this. This is the solution of a problem, right? Problem number 17. Problem number 17 over. Now let's move towards second last problem, that is equals to problem number 18. So what is their problem number 18? In a problem number 18, a pipe open at both ends has a fundamental frequency. Okay, there is a pipe is there which is open at both ends. Its frequency is equals to V upon twice L, which is equals to, which is given, that is equals to 600 hertz, which is equals to 600 hertz. The first overtone of a pipe close at one end. Okay, first overtone, the frequency of the first overtone of a pipe close at one end, that is equal to twice V upon twice L. So this is the frequency of a first overtone, that is equals to twice N. This is frequency of first overtone, isn't it? This is the frequency of a first overtone, right? So this frequency of a first overtone of a pipe close at yeah, here it is. The frequency of a first overtone of a pipe close at one end has the same frequency as the frequency of the overtone of the open pipe. So this is the frequency of a first overtone of a open pipe. Okay, this is right, but this is equal to frequency of a first overtone of a pipe which is at a close end. Now the first overtone, in a first overtone, what in a pipe close at one end, we have the situation like this, right? So this is the frequency of a this particular overtone. Say this is length L, right? Here will be a formation of N node, here will formation of node, here will formation of anti-node. So L will be is equals to N in distance between these two node, that is equals to lambda by 2 plus distance between this node and anti-node, that is equals to lambda by 4. So this will be is equals to 3 lambda by 4, right? So that is equals to L. So lambda will be is equals to 4L by okay, just hold on second. So it will be is equals to 4L by 3. Okay, lambda is equals to 4L by 3. The frequency here in this case I'm going to consider N1 dash, right? Because N1 already mentioned over here, frequency of first overtone of a pipe open at both end. But N1 in this case, that is nothing but a frequency of the first overtone in a pipe close at one end. So that is equals to N1 dash, that is equals to V upon lambda. So V upon lambda is equals to what? That is equals to 4L by 3. So 3 will go to the numerator. The frequency N1 dash will be equals to thrice V upon 4L. But this is equation 2. This is equation 1. But in our problem, they gives you frequencies are equal and pipes are length of the pipes are different. So this is L1. I'll take length. I'll take L1. In this case, you can take a length L2. Take L2, length L2. Okay, take this length L2, and this they said that what it is, they said that this lengths are these frequencies are equal. If these frequencies are equal, then we can say that N1 will be is equals to N1 dash. So what is the value of N1? That is equals to twice V upon twice of L1. This 2 will get cancelled little later, L cancel little later. So this and N1 dash is equals to thrice V upon, this is the formula, thrice V upon 4L1, thrice of V upon 4L2, right? So this is 4L2. So what exactly here is the situation right now? Okay. So 2 will get cancelled, so I'll write over here. Okay, so what it is, 1 upon L1 will be is equals to 3 upon 4 L2. So that means L2 will be is equals to 3 by 4 L1, right? So we have this situation, but from this problem we can say like that, what is value of L1, what is value of N1 frequency, that is equals to twice N. So twice N means, that means double of this N, that is equal to 600. That means 2V upon twice L1 or V upon L1 will be is equals to, we can say that 1200. Okay, let's move little lower, right? They gives you N1 is equals to twice V upon L, or in other word what we can say that n1 is equals to n1 is equals to twice n, and n already we have that is equals to 600, so n1 will be is equals to 1200 hertz. So n1 we have, what is the value of n1? That is equals to v upon, what is n1, what is n1 formula? Or here this is the formula of a n1, that is equals to v upon l. This 2 and this 2 will get, this 2 will get cancelled, v upon l1 it will be, right? V upon l1, right? V upon l1 here, I'll write down v upon l1 in this case. But is it the speed which is mentioned over here? Is it the speed is mentioned there? No speed is mentioned, right? So okay, so I think 330 meter per second or 340 meter per second you can take over here, right? So l1 will be is equals to 330 divided by 1200, right? The value of v, I'm going to plus 330, I'm going to take l to this side, and this 1200 will come to this side, right? So 0 0 will get cancelled, 33 divided by 120, that is nothing but an answer of your question, right? If you just divide it as, if you just divide, okay, I'll divide for you. Okay, okay, say calculator, I'm taking calculator. Okay, it is even with the help of bare calculation also you can do. 33 divided by 120 you wanted to do, so take a 33 divided by 120, 1 2 say 0, that is equals to how much? 0.275. This is 0.275 meter, 0.275 meter, right? So answer of this question is equals to 0.275 meter, and in a centimeter that is equals to 27.5 centimeter, right? So this is the answer of this particular question. So 27.5, yes, here it is mentioned 27.5, and put the value of L1, that is equals to, in this formula, that is 27.5 centimeter. You can multiply, divide, and you will get this value, right? So this is nothing but a L2. This is the